right, so let's take this first example here. Now, what are we going to do with this? I want to maybe put this on another page. Okay, now if I want to isolate, I know this looks really hard, but it's not that big a deal. If I want to isolate M1, what do I have to do to both sides to isolate that? Now this is just like the stuff we did the other day. If I can point at it, I can isolate it by reversing order of operations. I saw a hand over here. Yes, ma'am. Times both, well, okay, no, I know I don't need to. Now I know what you're getting at, but I don't need to because M1 is already there. My goal is not to move M1. I want to get M1 by itself on that side, right? I want to move everything else over there. So how am I going to move those other things? Yes, ma'am, Emily. Okay, multiply by not R2. How do we say that? R squared. Okay, so one thing I want to do is I want to get rid of this R squared. And if we look at order of operations here, I'm isolating, so I go in that direction, right? There's nothing to add here, is there? Right? There's nothing I need to add or subtract from both sides. It's all going to be getting all this stuff over to the left. And that stuff is linked by multiplication and division, right? So one step I've got to do is multiply both sides by R squared. Well, let's see what happens. So if I do that, that's good. The R squareds go away. Very good. What else? Okay, divide by, well, now that really is just an M2. That's not a square. Yeah, that's, okay, so divide by M2. If I do that, both sides. And that 2, that might be a little confusing. What that is, sometimes if we have like two different M's up there, we'll put a subscript next to them to distinguish between the two. Okay, so that's good. That's going to cancel that M2 and it puts it on the other side. And then what else? Just to make this look a little better, I'm going to do this. But say it again. Yeah, divide both sides by G also, right? So, and those cancel. And we're done, right? Now we've got that M1 by itself, and on the other side we've got the jumble of stuff that's equal to M1, right? Now when we write this, just another small point I want to make, it's perfectly okay for us to flip around which side has the M1, isn't it? I can put it on the left or the right. And if we're writing a formula, we probably want to put the M1 on the left side of the formula, right? And the other stuff on the right. But that's our answer. F times R squared, doesn't matter what order I put those in, over G times M2. And that's our formula. How about that? Okay? Make sense? It's just algebra. All we've done is just use the same steps we'd normally use. But instead of having numbers and X's, we had a whole bunch of symbols up there. A whole bunch of variables and constants.
Question?
Yes?
Wouldn't it be easier just like move the M and then just move the F instead of trying to move three different things?
Okay, good question. But now, what's going to happen? If I try to move the M, how am I going to get the M to the other side? To get it to the other side, I have to divide it. It ends up on the bottom. See the problem?
Alright.
Well, I mean, then we could flip both sides or something, but that's starting to get a little complicated. Right? Now, I will say this, though. I think what you're getting at is we made 3 steps there. Probably we could do that all in one step, right? I mean, we could probably say, okay, everything, if we go back to where we started on this, if we go back to where we started, we could say to ourselves, if I want to isolate that M1, everything that starts out on the bottom, we're going to multiply by that, so it ends up on the top, right? And we could probably get to our answer a lot quicker. We could say M1 equals, I already have an F on the top, so it starts there. I'm going to multiply both sides by R squared, so I'm going to get an R squared on the top also. what's gonna end up on the bottom? Well, those two things, the G and the M2, right? Does that make sense? So that's quicker. I mean, once we get a little practice at this, we can just do stuff like that. It makes it a lot easier. Okay. Does that sort of address your concern?
Yeah.
Okay. All right. So now let's backtrack and let's look at these other two. Or four. Sorry. Look at these guys. What about evaluating those? So we're gonna get a number. Now, let's start with an easy one. What's that equal to? Yes, sir. 4. Okay, because, how come? Explain to me why. Yes, sir.
Because if you multiply a negative with a negative, it's positive.
Good. And what this is saying, if I take a base to an exponent, which we call power, right? That's just telling me how many times am I multiplying that together, right? So this is literally -2 times -2, which is +4, right? Now what about this one? What's that gonna be? -8 for the same reason, right? Because this is literally saying -2 times -2 times -2. And what's our rule when we're multiplying negatives? If I take a negative base to an even power, which means I'm multiplying an even number of negative numbers, the result's always positive. Good. What if I take a negative base to an odd power? So I'm multiplying that negative number an odd number of times. Negative. Okay, so good. So this equals -8. Question?
That only applies if those pressures are negative.
Yes. Now, and let's talk about that. Now, what's going on with, let's say, this guy? This is tricky. What is that really saying? Is that -2 times -2, or is it negative the quantity 2 times 2? That's it, isn't it? Okay, and why is that? What this really means, and this is important that you see this, and this also addresses an issue with calculators that we gotta always be careful with. If I do -2 squared, it's actually -2 times 2, and I'll prove it to you. If we pull up a calculator,
Are you gonna still calculate?
yes, in fact, let me just say that right now. Okay, we are going to, how many people do not have a graphic calculator? Okay, do I have a deal for you? We're gonna do an order through the high school for TI-84 pluses, which are, that's very good. $78 instead of 100 and whatever at Walmart. 99 for the plus even? And this is silver edition plus, I think it's got, how much? 117, okay, ish, okay. So this is a very, very good deal. Question? Okay, oh, that he's holding it up, that's what it is. They're very nice, newest, latest and greatest. It's an awesome deal. I'll put color, I don't know if you can choose color or not. I'm not sure if you can. I'll find out. But anyway, $78. Let me double check and make sure that's right. I think that's right.
Last year, 75.
I'm gonna be embarrassed if it's not, but I think it is. Yeah, it's a good deal.
My brother has one that he uses for solar panels.
Hold up. Okay. Yes, 78. That's it. That's a great deal. $78. Here's what you gotta do. I need the money we're sending the order out on October 3rd. So between now and then, I gotta have the money. You can bring cash. Check is probably preferable. Make the check out to PHS. Anyway, that's a very, very good deal. You're gonna need these things all year. Every test that we do is, other than maybe the very, very first one, is gonna have 2 parts. There's gonna be a non-graphing calculator part where you can't use a graphing calculator, which is kind of algebra based. And then there's going to be a graphing calculator part where you will have to have one. And it's designed to help you take advantage of all the powerful stuff it does, like regression and statistical stuff and graphing and evaluating functions and all that, using tables. And I'll show you how to do all that stuff. Now, it's possible, we can probably find ways to get you one, but the research shows very clearly that when you have your own calculator, you do much, much better with it. And you're gonna need this in college forever. Take advantage of this deal. Questions? Yes?
So the order, so all the orders we ordered on.
Yeah, the order goes out on October 3rd. They'll be here, not long. Within a week, we'll have them here. And I just won't do a lot of graphic calculator stuff before the end of the week. So, okay. What other questions? October 3, great deal. Take advantage. Not quite. Not quite. Not quite. Now what was I doing? I was pulling up this calculator. Right. Okay, now watch something. Watch something here, please. Oh, it's frozen. You can't watch anything. You're right. Here you go. Okay, if I do -2 to the power of 3, so -2 cubed. And notice how these new calculators, they actually do stuff. Isn't that cool? It makes it look the way it's supposed to look. It doesn't look like a string of weird symbols. It actually looks algebraic. And then if I want to get out of the exponent there, just so you have an idea here, you just hit the right arrow always to get off of the exponents or out of a square root or something like that. Look what I get when I hit enter. -8. Right? Oh, that one we expected. Let me do -2 squared. -2 squared. -4, not +4, right? There's a difference. You told me that the quantity -2 squared was +4, and you were right. The calculator knows that too. Watch. If I put it in parentheses, it's +4, right? So clearly there's something going on there. The calculator's smart. It knows order of operations. It's right. That's the way it should be. How come? Well, because by order of operations, if you think about this, if we follow order of operations strictly, exponents will come before multiplication. And this 2 squared is at the exponent part of order of operations. When I have a negative sign out in front of something, always what that means is multiplying by -1, right? And so I don't actually multiply the number by -1 until after I've taken the exponent. So, moral of the story, on your calculators, if you want to take a negative number to a power, what do you always have to do? Put it in parentheses. Very good. Okay. You know what? I think just when do we get out of here? 50?
Yeah.
We better go now. Let's try. Let me see if the lab's open. Hang on.